Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Stephen Feuerstein, and I'm a PLSQL developer just like you. This lesson is a part of my series on programming with collections, the array-like structures in PLSQL, and the focus of this lesson is, using collections inside SQL. Some quick reminders. If you haven't already done so, visit PLSQL Obsession, toadworld.com/sf, where you can download all the code that I will be running in this lesson and other lessons, as well as PowerPoint documents for many of the trainings that I present. Make sure you're comfortable with the material covered in the previous lessons in the series. Generally, you want to know what a collection is, how to work with collections, and particularly working with nested tables and V-arrays, because those are the only two types of collections that you can reference and use within SQL. So using collections in SQL. We'll start with an overview. We'll take a look at collection types as column data types, one way that collections can be used inside SQL. We'll take a look at using the table operator and also changing contents of collections and columns with the table operator, though usually it's used to query data out. And we'll finish up by taking a look at using the multiset operator to convert data in a relational table format to a collection format. So first of all, an overview. When you define your collection at the schema level, not inside a PLSQL block, then collections declared with that type can be referenced inside the SQL layer. Basically, by declaring it at the schema level, it becomes known or available to the SQL engine. And there are basically two ways that you can be working with collections inside SQL. One is as a column in a relational table, and the other is by selecting from that collection in a select statement or modifying it through an update statement as well. This feature only applies to nested tables and to V-arrays. Associative arrays are PLSQL only structures. They cannot be referenced in SQL statements, at least not directly. You could access them through a function interface, but that's really not the focus of this talk. Now, generally speaking, Oracle offers a way to translate between a collection format, the nested table and V-array, and a relational table format. Essentially, use the table operator to move from a collection to a relational table, and use multiset to move from a relational table to a collection. Let's take a look first at using the table operator. We'll use table to work with data in a collection as if it were data in a database table. Oracle refers to this process as unnesting. You've got a nested table, and the idea behind the nested table name is that you can nest it inside a table as a column type. And so if you unnest it, you're taking it out of that column structure and you're moving it into a format that can be used inside an SQL statement. This is especially useful when you'd like to apply SQL operations to a PLSQL collection. For example, even one that's not stored in a database table. And in Oracle 10 and higher, you don't need to explicitly cast the collection. Cast is a mechanism that you can use to convert from one format to another. And in the older versions of Oracle, you might have to cast a nested table as its type. No longer necessary. Oracle will figure it out for you automatically. Let's take a look. Again, this is one of the many files that you can access in the demo zip that you can download from toadworld.com/sf, PLSQL Obsession, collections in SQL. So what I've done here is declare a type, names T, as a nested table at the schema level, so not inside a block of code. And I can declare it as a table of strings. Inside my PLSQL block, I'm going to declare a local variable based on that schema level type. I'm going to assign it the names of 3 people who currently work at Oracle. Who knows, by the time you read this, maybe things will have changed, but Larry Ellison, Thomas Kurian, and Bryn Llewellyn, the current PLSQL product manager. And what I'm going to do is demonstrate how I can blend together data from a relational table, the last names of employees, with the data from my local PLSQL variable. So notice this collection is not inside a database table. It's not a column of a table. It's just a locally declared collection, but still, because my type is defined at the schema level, I can merge this data together. So what I'm going to do is select column value. That's the hard-coded fixed name that Oracle provides for the column value of a nested table of scalars. strings, dates, numbers, etc. I can, of course, rename it to anything I want. And I'm going to select from that collection, but I'm going to do so by putting the reference to that collection inside the table operator. So basically this says take this nested table, convert it to a relational table format, and then select from it. And when I run my code, I see the following. Here are the various names of the members of the employees table, and then we should see Ellison and Kurian and Llewellyn. So the data is blended together. And that's the basic idea. There's not a whole lot more to it than that. The table mechanism, the table operator, allows me to treat my collection as if it were a relational table. Now let's try one more thing, which is to take the definition of my nested table and put it inside my local block. And let's change the name of the type to make it different from the schema level type. And let's try it again. Now it's saying I encountered the symbol table when I expected one of the following. Object opaque, I'm not really sure why it's expecting one of those, but the bottom line is that because my collection, LNames, is now based on a local collection type, Oracle is not able to understand what this collection is, how to apply the table mechanism to it to convert it into a relational table format. So this technique will only work with schema level defined types. But once you've got it there, you can go at it, select from it, have a good time. You can also use the table operator to change the contents of a column in a table that is itself a collection. And this can be used with nested tables to change individual column values in a collection. But if you've got a V-array as a column data type, you have to change the entire V-array. You can't replace individual elements. I'll show you how you can use the table statement, the table operator, to change the contents of a nested table. So what I'm going to do is create a relational table that has within it columns that are of type nested table. So I'm going to declare a family table. It's got the surname or last name. It's got the list of parents, the list of children. So here's an example, and each of these are themselves nested tables. A list of strings length 100, same thing for child names. So what you see here is an example of Oracle officially supporting denormalization of data. Usually you'd have separate tables with the names of the elements, if that made any sense at all. Anyway, separate tables, and you would join them together to get all the information gathered together. But in this case, we've actually got the separate lists inside the family table itself. This makes sense from an object-oriented standpoint, even if it doesn't make so much sense from a relational standpoint. So depending on the model that you're choosing to define your application and build your application, you might choose to take this approach. Otherwise, you might stick with the relational normalized database design. The bottom line, though, is that Oracle lets you do it. I declare my nested table types. I create a table using those types as my column types. And when I'm working with nested tables, I also have to specify the store as. It's basically the name of a table that will hold the information in these different nested tables. And the reason is that these tables can get arbitrarily large, and Oracle stores the data for them offline from the rest of the row in the family table. And you can check the Oracle documentation for lots more detail about the nested table store as clause, including how you can specify the table space and other aspects of the storage of that nested table structure. V-arrays do not require this structure, this specification. So I create my table, and then what I'll do is insert into the table a particular set of data. I'll insert in a row for my family. That's my last name, even though it's not my wife's last name. The names of the parents are Stephen and Viva. The names of the two children, Chris and Eli. So let's first run all of this code and populate my table. So I'm going to drop the table, I'm going to create my types, recreate my table, and run my program. And then if I look at the contents of my family table, I will find that the data is in there. So Stephen and Viva are the parents. Chris and Eli are the children. Excellent. So that worked. I can do an insert into the table. This is an example of using a nested table in the SQL layer as a column data type. But what I especially want to show you now is how I can change the contents of elements of that nested table. So what I'm doing here is changing the name from Eli to Eli Silva. His middle name is Silva. He has my wife's maiden name as his middle name. So I want to add that name in. So what I need to do is find that particular element in my nested table and change it. So I'm going to update. Well, I'm not going to update the family table directly. I'm going to get the children names nested table from the family for a particular row. That's what that select statement does. I'm going to convert it into the relational table format using the table operator. And then I can make my changes. So what you see here is that Oracle will actually go through the nested table that's pulled out of here, find a match for the column value, and for every row that matches, change the column value to Eli Silva. When I run this code, look at the contents of my table, and look at the children, I now see that Eli's name has been changed to Eli Silva. So it works. So the table operator is most commonly used to retrieve data out of the collection in a select statement. But if you do have your nested table defined as a column in the database table, then you can also use the table operator to drive an update into that collection and also do inserts and deletes. Now let's take a look at the opposite approach, which is I've got data in a relational table format, a query, and I would like to retrieve it and transform it into a multiset or a collection format. And to do that, I use the multiset operator. It's the inverse, the opposite of table, converting a table viewer query, basically the rows and columns of a select statement, into a V-array or a nested table. And I can use multiset to essentially emulate or transform relational joins into collections and basically retrieve all of this data in one pull from the database, drop it into my collection, and thereby reduce the client-server communication and get an improved performance. And the example I'll look at has to do with birds and species of birds and their habitats. So let's just take a look at the file. Oops. So I'm going to create a table of birds. And birds have a genus, a species, the colors of the bird, and the colors is a V-array. Maximum number of colors, 16. And the primary key is on genus and species. So, for example, I'll insert a couple of rows into the bird's table, the spiroglockial, the blurring tumswitch, and they include a list of colors. So the color array, a spiroglockial, has red, yellow, and green feathers. The blurring tumswitch has brown and orange. So I construct my V-array on the fly with my constructor function. It goes into that table, and let's go ahead and try that, just those first two steps, and verify that the data is in the table. Let's commit the changes. Let's look at the birds table. And there are the colors, red, yellow, green, brown, orange. Notice all the commas. The reason you see these commas here is that when I'm using a V-array, which is what we've got, a V-array, it says the maximum number of elements are 16. So Oracle has actually allocated room for 16 values, 16 colors, but it's only used 3, or in this case 2. So that's why you see these commas here. You don't see them for nested tables because you don't specify a maximum number of elements with nested tables, and therefore Oracle does not allocate the elements. All right, so I've got my list of birds defined with their colors. Bird habitats. So basically, where do the birds live? And this is just a set of column values, no nested tables here. So let's create that data. And then after that, we'll take a look at what we're going to do with all that data. Run my script. Saved my changes. Great. And finally, what I'm going to do is retrieve the genus of the bird, the species of the bird, and then I want to get all of the bird habitats, the places the birds live, as a single set of data. So I'm not going to do a join. Notice there's no join here. I'm not joining birds to habitats, etc. From within the query itself, I'm going to retrieve all the habitats for that bird. And that's a select statement. That's rows and columns. I'm going to use multiset to convert it to a nested table or V-array format, a collection format. Now that's a very generic statement. Convert it to a collection format. Now I have to use cast to convert, to specify what kind of V-array or nested table I'm passing it out as. So cast all of this data as country tab. And country tab is a table of strings. Then in my code, I'm going to open and fetch that row of data from the collection. I'll display the countries, the header, countries in which the bird row genus is found. So I've retrieved a single row of data, and that single row of data has within it an array of countries. That's the name of the column. So retrieve that collection, the rows from the bird habitats table as a collection. Drop it into that single fetch, that single record. And now for every row that I fetch, for every country in my collection, starting with the first, I'm going to display the name of the country. And then go to the next country row, or the next country element, until all the countries have been displayed. So I looked up the information for the spiroglottal. I found that it was in 3 countries: Halban, North Ottawandia, and Spalaker. And all that information, I certainly could have done it with a join, but in this case, I retrieve it in a single row of data back from the database without needing to join up the data. And I was able to transform my rows and columns in a select statement into a VArray format, in this case a nested table format. Let's make sure of that. A nested table format. And then I can use my collection methods to iterate through the contents of that collection. Conclusions. One of the key advantages of both nested tables and VArrays is the ability to use them within the SQL layer. Now, I must admit, if you're not doing object-oriented design and development in an Oracle environment, this will be of less interest to you because you will stick with a normalized database design, and you will not have columns and tables that are themselves nested tables and VArrays. But still, you can use the table operator, and I'm sure you will use the table operator, to take data inside your nested table and VArrays. Remember, they don't have to be in tables. They can be locally declared collections as long as they're based on a schema level type. And then you can use the power of SQL to manipulate the contents of your collections. So if I've populated a nested table with a bunch of data, programmatically, I might not have even queried it from the database originally. And now let's say I want to sort the elements, or I want to search for specific elements. Well, I can use an SQL statement and a where clause, or an order by clause, on the data returned by using the table operator. So it really gives you the ability to combine the power of collections, the speed of collections, with the elegance and the set level operations of the SQL language. And then, if need be, you can use multiset to manipulate the contents of a result set as if it were a collection. So in that case, you want to use the programmatic capabilities of traversing through a collection, making changes to elements in a collection. And so you get the data out as a query, convert it to a collection with multiset, and off you go. So these are tools that you can use to move between the formats that make the most sense to you and the specific requirements you have. Next steps. If you haven't already, download that demo zip file that contains about 20,000 scripts with all the code that I demonstrated today. Go over each of the lessons, try out the code yourself, make sure that what I said makes sense to you. Did you understand it? And then explore the other advanced topics for collections, working with non-sequential indexing, using string indexed associative arrays, a very powerful and interesting technique, and using the multiset set level operators. The multiset that I've referenced in this lesson has to do with converting select statements, result sets, into collections. The multiset operator can also be used to perform unions, intersects, and minuses on nested tables. So it's the same keyword, but it's used in different ways. Check it out. It's really amazing stuff. All right, well, I hope you enjoyed this lesson, can put it to good use in your own application development, and happy PLSQL coding.